Hi again, I'm Hank Venema, the CEO and Senior Engineer at Strategic Systems Engineering. In this video, we'll look at how to evaluate the costs and benefits of natural infrastructure for climate adaptation. As we've discussed, increased heat from climate change leads to increased evaporation, causing more drought conditions and eventually heavier clouds, more intense rainfall events. Consider this fictional area. They have a water treatment plant. There's a town here inside this municipality and inside this watershed. There's many assets, stores, cropland, houses, even a factory, all of which have their own damage function appropriate to that type of building. It begins to rain, the rain flows over land, flows into the river starts to rise, and there's damages to all of those assets. We'll use the LiDAR and the ground elevation of the buildings and the damage functions provided by Public Safety Canada to estimate the flood damage cost to those assets as a dollar figure. Now we can combine the flood damages for all of those assets, sum them all up to calculate the full flood damage for that particular event. This dollar amount of flood damage is for a hypothetical 1 in 20 year flooding event and is the sum across the whole region of interest, probably a municipality or the watershed. Doing nothing means every year we're exposed to flood risk, and over 50 years, that adds up to a lot of expected damages. Climate change adaptation means investing for the future and reducing these risks for our benefit and for our children's benefit. So what should we do? We recommend using LiDAR to design natural infrastructure projects that provide flood and drought protection and other important benefits. For example, if we build a project like Pelly's Lake, we reduce the flood damages. During a summer drought, we can release water from the reservoir to provide water for the water treatment plant. And if we combine the concept of harvesting biomass from the site when it's dry in the fall, we also create a water quality benefit, a habitat benefit, and we have an economically valuable resource, the biomass itself. How do we calculate all the benefits? Let's focus on flood protection firstly. Let's assume the project costs $1 million. We need to compare this against the benefit of reduced flood damages in future years. We can estimate the benefit cost ratio of the project to help establish its investment case. Let's assume the project costs $1 million to build. So let's compare that to the first year of reduced damages. The cost ratio of year one is, say, $200,000. So let's take that benefit of reduced flood damages and divide it by the project costs. So that's $200,000 of benefit as reduced flood damages divided by $1 million. That equals 0.2, which is not a very good benefit cost ratio, and that would mean this is not a good investment. The thing is, the project creates benefits for a long time, so let's look at the next 50 years. To calculate the benefit cost ratio over 50 years, we add up the benefits through years 1 to 50 and divide by that same $1 million initial project cost. We've got a benefit cost ratio of 4.0, which is very good, and this project should be implemented. Infrastructure Canada has recently changed the rules for funding eligibility under the Investing in Canada Infrastructure Program, specifically encouraging natural infrastructure projects. Infrastructure Canada now allows us to stack benefits to calculate total project benefit cost ratio. Natural infrastructure projects like this create benefits beyond flood mitigation. They include drought mitigation, biomass production, habitat protection, water quality protection, and recreational opportunities. We can do all of this analysis, which is greatly facilitated by the availability of LiDAR provided by the Government of Manitoba, the infrastructure damage functions provided by Public Safety Canada to estimate flood risk and flood risk reduction benefits, and modern flood risk models such as WDPM and Telemac that can process the LiDAR. The case for natural infrastructure projects increases with climate change. Climate risks are higher, but so are the benefits of protection. In an earlier video, we used the IDFCC tool to see how climate change and the accumulation of greenhouse gases in the atmosphere leads to an increase in 1 in 20, 1 in 50, 1 in 100 year precipitation events, and therefore more flood risk. Before climate change, a 1 in 20 year flood would still be costly. With climate change, that cost is greater yet. The risks are getting higher, and doing nothing will cost us more and more. On the other hand, investing for the future will save us more and more because the benefit of proactive climate adaptation will only increase. Thanks for watching this video series. To learn more about how we can create climate resilience using LiDAR processing, climate risk analysis, and engineering design, visit our website strategicse.ca and check out the redriverbasioncommission.org for more information. Thanks very much for watching. Talk to you soon.